I'm going to talk about a sensor from FRSky to monitor your voltages while you're flying. I decided to try this sensor because I don't like these sensors where you monitor your battery voltage by plugging this into the balance port. I end up forgetting to plug this in, so many times I go to fly my plane and I've got no voltage going on. And the other problem with this sensor that is really bad is it's not voltage polarity protected. If you plug this in backwards to the balance port, you're going to fry the sensor and you're going to fry the receiver. Not a very good sensor. The one with the OLED display does have voltage reverse polarity protection on it, but you still have to remember to plug it in. So I'm not a big fan of this type. So this sensor is actually an ammeter and a voltage sensor, but I'm not going to use the ammeter part because in this particular sensor it only can go to 7 amps, and the average model is drawing way more than 7 amps. So I'm just going to be using the input side. You can see it's labeled in and there's an out section. I'm just going to solder the battery leads to the inside of the connection here on these two solder pads, and we're not going to use the ammeter part. The ammeter would be where you run the motor through this board. Well, I'm sorry, not the motor, but the battery through this board. And we're not going to do that because with 7 amps, the board would not be able to tolerate the high amps for like a 50 or 60 amp type of airplane. So I've got one soldered up, and this is what I ended up doing. I soldered a regular servo lead to the input pads, and it comes with a piece of heat shrink, so I decided to put the wire over the board to act as a strain relief, because otherwise if you came out to the left side, I don't think that would hold up. You'll end up eventually breaking the wires loose on the board. So solder it over the board, and this way you get a good strain relief on it. Now this connector here goes to the receiver, to the smart port on an FRSky receiver. Now, interestingly enough, these receivers are a little different. I've got two X receivers, one being an 8-channel and a 6-channel. And as you can both see, they both have the smart ports on the left side, so it's easy. So you take the connection on this board and run it to the connection over here. But now on the gyro receivers, it's interesting. The S8R and the S6R are different. The 6 does not have a smart port over here. This is an LED display there. And the 8-channel is like the X receivers. It's out the left side, no question marks as to where that goes. So on the 6, it's the first port labeled S port, which is actually smart port. And it goes to the top connector on the right side of the board to plug it in there. So what I like to do, I like to solder an extra pair of wires to the ESC. This is going to my ESC. And I solder an extra servo wire connector to the ESC because this is where you need to get the full voltage of the pack. And I like to put it on the servo connector. This way I can disconnect it so it's not physically tied to that. Now obviously you could solder this directly to that if you want with some wires. It's up to you. I just like to put it on the connector for flexibility. So on OpenTX, I'm going to show today how this works. And I'm going to plug a battery into the ESC. And let's hit the MDL button. And oh, by the way, I'm using a RadioMaster TX16S running OpenTX. But you could use an FRSky Horus radio, for example, or a Tarranis. This should work. And it should also work on Edge TX. There shouldn't be any issues there. So let's page backward to the telemetry menu. I'm going to scroll down, and first time we set up a receiver, we have to do discover sensors when you add a new sensor to a receiver. So we're going to go here, discover. This only takes a few seconds. I'm now going to hit stop. And in this particular case, it put the voltage on sensor 2, but don't go by the number. The number is totally random. It could, the next time you bind a receiver up, it could be 5 or 3. So don't worry about the sensor number. But I like to change the label of the sensor. I don't care for the word VFAS. So let's press enter on that, edit, and I'm going to change this to the word volt. This way it'll show up better on the screens. Okay, so once we have it set up, we return out of that. And let's go into logical switches. So what we want to do is set up a condition where we say if the voltage is below a certain value, we want to set up an alarm. So let's press enter, and we're going to pick A is less than X, press enter, and pick telemetry. And then we have to look for the word volt. So don't pick volt plus or volt minus. Those are what was the highest voltage and what was the lowest voltage. You want the real-time voltage, which is just volt. Press enter. And now you have to set up your low voltage alarm. Typically, maybe you want to set up like 3.7 or 3.8 volts per cell as your low voltage, but that's up to you. You might want to go lower to 3.6. So for this test, I'm just going to pick a number. We'll pick like 10.8. And we'll say if it's below 10.8, we're going to sound an alarm. Now, what I like to do here, this is a bench thing. On the bench, I don't like to listen to low voltage alarms. I might use a pack that's not fully charged, and I don't want to hear about low voltage alarms. So I'm going to tie it to my throttle lock. I'm an electric flyer, and on the bench, I absolutely lock my throttle so I don't accidentally engage the propeller. So I'm going to use an AND condition. I'm going to press enter here. I'm going to move my throttle lock switch, which in this case is SB. And right now, throttle is unlocked. That's what I want, SB up. I'm going to press enter. Now, when the throttle is locked, I won't hear about a low voltage alarm. So we'll hit return for this. Let's go over to special functions, and now we have to use the logical switch and tell it what to do. So we'll pick a special function that's open. We'll pick 1 for this test. And we'll do a long press, and we'll pick logical switches. We'll pick logical switch 01, which is where we just set that up. And now we're going to play a track. So look for play track. There it is. And over here, you pick low voltage or low battery. There it is, low battery. And now that's going to announce a low battery when the voltage is below the value you set. So we'll hit return. Now I like to do another function. We'll pick another open special function. We'll just pick 4. Press enter. And I'm going to say again, if the throttle is unlocked, I don't want to listen to this while I'm on the bench. And I'm going to say if SB is up, meaning it's unlocked, we're going to play a value. So pick play value here. There it is, play value. And now we're going to pick telemetry. And we're going to look for the word volt. There it is. And I'm going to announce the voltage
11.5
every
volts.
20 seconds. So while I'm flying in real time, this is going to announce the current voltage of the battery every 20 seconds. And because it's tied to my throttle lock switch, when my throttle is locked on the bench, I'm not going to hear that 20-second announcement.
11.5 volts.
So that's how you would set up OpenTX. Now maybe you want to put your voltage on your main screen. So let's return out of there. We hit the telemetry button. We set up widgets. And let's say we want to put the voltage right here.
11.5 volts.
I'm going to lock the throttle so I don't have to listen to that. So you use your cursor and highlight the box you want so it's in solid red line, no dashes. Dashes means it's not selected. So pick the one that's solid line. press enter, and you want to look for value. There it is, value. You press enter on that. Now we have to pick the source. It defaults to rudder, so again you press enter. We're going to pick telemetry, and we're going to look for the word volt. There it is. Again, don't pick volt plus or minus, because that's what was the maximum voltage and the lowest voltage during the flight. You want to pick real-time voltage, which is volt. You can pick your color here. For this test, I'm going to leave it as white. We're going to escape out, and there we go. So now we have the voltage on the screen, and that's real-time voltage. Maybe you want the voltage on the top bar. You could do that also. You would tab over to top bar here. And now same thing. You pick the box that's a solid line without the dashes. So maybe you want it on the second box. Press enter. And again, move over to the word value. Look for value. There it is, rudder value. Press enter. The source is going to be telemetry. And then we look for the word volt. And again, I'm not going to worry about the colors. And so there. So you could put the voltage here. You could put it up there. It's up to you. So now you've got voltage based on sound or on display. One other thing to note that was a little odd. When I picked this sensor up, it came with this little index card in the packaging. And I was a little surprised. The specs here say 16 volt maximum voltage, which I don't understand because the web page said 32 volts. I went to the FRSky website, downloaded the PDF manual to this sensor, and the PDF says it's 32 volts. I checked a couple other websites. They said it was 32 volts because 16 volts, you couldn't even do a 4-cell pack on this. I said, let's try it. I put a 6-cell pack on it. It works fine. It reported the voltage great. It didn't get hot. I left it plugged in for several minutes. There was no issue. So I guess this is just a typo on the little card that comes in here. I don't have an 8S pack, so I can't test anything higher than a 6S, but it worked fine.